Hello, my wonderful AP Physics 1 students. This is Mr. Jockmans, and I'm here to help you understand what you need to know for the second day of AP Physics 1. These videos are helping to prepare you for the next day's class and the activities, lessons, and labs you'll be doing based on this information. I expect a couple things from you as well while watching this. I expect you to have your physics notebook open and to take good notes on what you're learning today. When there are questions I have you answer in these videos, there's none today. I expect you to be able to write them down and answer them while doing the video. I also expect you to be able to actually pause, rewind, or do whatever to help you learn while watching these. If there's a question, pause, think about it. If there's something you don't understand, rewind. And finally, you may not be comfortable now, but soon, hopefully, you can come and tell me what you didn't understand, what didn't make sense, what you're uncertain about, what worked, what didn't work, what needs to change with these videos. I make them to make you have a better experience in class. If you think there's something that you need to know, let me know. I implore you. I have a couple goals for you today. This video will give you a strong head start in the year. We're going to learn some very big ideas that are constantly used. We're going to discuss the ideas of position, displacement, velocity, and their definitions. We're going to see how they relate to each other through math and through pictures. We're going to learn some key terminology such as change, x-motion, and the idea of a net. So to start us off, this first topic is called motion in a straight line, also known as one-dimensional kinematics. By one dimension, we're going to be talking about the forward and backward direction, also known as the x direction. Imagine a car that can't turn left, can't turn right, can't go up, can't go down, can only go backwards and forwards. That's the kind of motion we're talking about. We'll expand on that soon and eventually talk about motion both up and down, left and right at the same time, motion going in a circle, motion rotating, motion doing all kinds of crazy stuff. But we got to build our foundations first. The goal of this topic is to help you describe, calculate, and predict where an object is, how fast it's moving, how fast it's speeding up or slowing down, and the future motion of an object. Again, only in one dimension, forward and backward. We're going to use graphs, maths, and relationships to do those things such as describe, calculate, predict. So the key vocab words. There are 3 right now and 2 more in a little bit. The first major vocabulary idea is the idea of position, represented by x. And it is where an object is at some moment in time, called t. And finally, the position of an object at the beginning of some time period is represented by x naught, or x0. But let's call it x naught, please. We're pretentious. Now, displacement's a little bit different. It's represented by delta x. That little triangle is the Greek letter delta. So delta x is displacement, x is position. Displacement is how far the object is from some chosen starting position. Position's where you're at some time. Displacement's how far you went in some time. Finally, velocity, represented by v. Velocity is how fast it's moving at some time. And the velocity of an object at the beginning of some time is called v naught. So if you have a car that goes from like 0 to 50 in 2 seconds, 0 is v naught, and after 2 seconds, the velocity is 50. So let's go in depth. What's going to happen here is I have some pictures, actually little mini animations I made to help you understand the 2 major ideas of position and displacement. Velocity we'll tackle in class. It's a little bit tougher. Here's a number line with something starting at position 0. That's where it's at. Now, it then moves from 0 to positive 2 in time period t1. So at the beginning of t1 it was at 0, at the end of t1 is at 2, as stated on the left-hand side. It starts at position of 0 and goes position to 2 in time t1. Now, since it started at 0 and ended up at 2, its displacement is going to be positive 2 units for that time period t1. So here we are. It's now at it's now at a position of 2. It's now going to go again another distance and end up at 3 in time t2. So at this point, the position is now 3 at time t2, and the displacement for time period t2 was 1 unit. It started at 2 and ended at 3 for time period t2. Overall, however, there's a little different story. I want you to think about the overall motion as the idea of its net motion, as represented by the Greek letter sigma that you see there. So in this case that we just looked at, the object went from 0 to 3 in time periods t1 and t2 combined. So let's call the overall time t, which is t1 plus t2. In that case, the overall displacement is 3 units for time t. The displacement is 2 units for t1, it is 1 unit for t2, and combined it's going to be 3. Now, this is a pretty tough point for students to understand in a more complex setting, but I think you guys will be able to get it. The idea of overall depends on where you start. So if in this problem I said, what is the overall or net displacement for t2? An answer of 3 is not correct. For t2, the overall displacement was 1 unit. An overall displacement of 3 is true for t1 and t2 combined. So the idea of starting and ending is completely arbitrary. It's usually defined by the physicist or the problem. Let's continue. Number line. The big thing here is that positive and negatives definitely matter. So let's start at -2. Please watch and see the motion of this object. It goes left 1, it goes right 4, and then goes back left 3. I'm going to make a little table of the position-time relationship. Notice what I did here. At time t0, or in another case, at the first moment we're looking at, it was at 2. After its first motion, t1, it went to -3. After its second motion, it went to 1. After its third motion, it went to -2. There are 3 different displacements here. Mathematically, we have a new relationship. You could write this down with our original definitions for displacement. Displacement for each time period is how much it changed by, the position. So delta x is just the position at the end of the time minus the position at the beginning of the time. Warning, like the starting position x0 is the previous position for the displacement, not the overall, unless you're looking for the net or overall displacement. So for t2, which is the blue line, x is 1, x0 is -3. If you're looking overall, however, things are different. And again, just to show you, for t0, it went from -2 to -3. The displacement for t1 is going to be -1. But the net displacement in this case is going to be 0 because it started at -2 and ended at -2 after times t1, t2, and t3 combined. If you understand that, you're going to do really well in the next little bit for the second day of physics. It's to get more complicated, definitely, but these first steps will get you to where you need to be. Thank you for listening, and I will see you on day 2